Okay, so looking at the h value of a quadratic. So h values are inside the brackets here. Okay, so when we're looking at the h value, what it actually does is move the graph left or right. If we consider this graph right in the middle, this x squared, which there's already an arrow, but I'm going to make another one. That's the general graph, the x squared graph. Whenever we're moving to the right, this is actually wrong. Whenever we're moving to the right, the graph always has a negative inside the brackets. Okay, so the negative inside the brackets moves it to the right. A positive number inside the brackets moves it to the left. So if we want to move left 2, we've got x plus 2, and that's moved our vertex, the starting point, to the left 2, and then we would have our normal step pattern, over 1, up 1, over 2, up 4, over 3, up 9. And we're going both ways. Remember our step pattern, we go over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4. Okay, and that's our regular step pattern. Okay, if we wanted to move over 4, we'd go to the red line. It would be x plus 4. Going the other way, x minus 3 moves us 3 to the right. X minus 6 moves us 6 to the right. So the general graph, or the general equation actually has a negative in it. So if we're looking down here, it has a negative in it, and that's why when we have a negative here, we're moving to the right. And when we have a positive, we're moving to the left. Okay, because two negatives would make it positive. Okay, the double negative here, x minus 5, with the minus there, would be x plus 5. Okay, so this is a positive 5 in the equation. If that was a negative 5, if we wanted to move to the left 5, it would make this value a positive value. Okay. Really, if you just remember the negatives move to the right, so like x minus 5 would be 5 to the right, x plus 5 would be 5 to the left. That's all you need to know. Okay, so the h term moves the graph, moves the starting point left or right. Okay, and it's always going to be the opposite of what the sign is. So if I look at these graphs, describe the position relative to the x squared. The numbers in front, or the negative sign, remember, all they are stretch and compression and then flipping the graph. So this first graph is right 7, because the number inside is a negative 7. It moves to the right 7. The next one is left 3, because again, that's a plus 3, so we're moving to the left. We're always doing the opposite direction of the sign in the bracket. And then finally, we've got nothing in the bracket, so this has no change. It's just going to be vertically stretched by 2. Okay, write an equation for a parabola that is translated to the right of the y-axis. So we need to move it right. So all we have to do is make sure that inside our bracket, the number is negative. That graph has been moved to the right. Okay, the next one, we have to move to the left. So we have to have a positive. That graph has been moved to the left. Is on the y-axis would mean that we haven't moved at all, left or right, so it's just x squared. Okay, so now we're putting some of the things together. We've vertically compressed it. We're opening up. Now remember, opening up means we have a positive number at the start. We vertically compressed it, so it has to be a number less than 1. So we've got 0.5, it has to be positive. Now it's got a vertex of 5, 0. So that means that it's moved to the right 5. So we need to put that in our brackets and move it right 5. All right, the next one is vertically stretched, opens down is negative, vertically stretched is just a number bigger than 1, and our vertex is negative 3 and 0, so it's moved left 3. So plus 3 squared. Okay? So when we're looking at a general quadratic, our vertex is always the turning point. Okay? It's our starting point of the graph. We've got an x-intercept. Those are important. X-intercept here. We've got a y-intercept. Those ones are kind of obvious. The other important things are the dotted vertical line, which is right here. That's the axis of symmetry. So axis of symmetry. And then the horizontal dotted line down here, that's the max or min value, depending if the graph is opening up or down. In this case, the graph is opening up, so that would be a minimum value. And it's always the y value of the vertex. This is always the x of the vertex, the axis of symmetry. And the max-min value is always the y of the vertex. Okay. Key features. So looking at this, so direction of the opening, is the top opening up or, okay, is it the opening at the top? If the opening at the top, then we're positive. Or is the opening at the bottom? If the opening's at the bottom, it's negative. So is it opening facing up? That's positive. Down, it's negative. Okay, our vertex, so this is the turning point. Okay, and the vertex is always our h and our k value. Okay, the y-intercept, where the graph crosses the y-axis, is also, we'll take that part out. We don't need that part. It's also the starting point, but it's not necessarily always the starting point. The optimal value, or the maximum or minimum value. This is the y-coordinate of the vertex, and it occurs at the x value of the vertex. So note also the x, as this is when the value occurs. Okay, so that would be like a word problem. The axis of symmetry is always the x value of the vertex. And it's always like x equals, and it's actually x equals the h value. Okay. Note that the value in the equation is the same as the h value, or the x coordinate. Okay, so our basic step pattern is over 1, up 1. We're always starting at the vertex, so then we're over 2, up 4, over 3, up 9, and we go both ways on the graph for that. If there's an a value, we always multiply the ups of the step pattern